A bunch of people at Google said like, yeah, we have language models that are way bigger than GPT-3, but we just don't put them in papers. The DeepMind language models papers, they were a year old when they finally put them out on archive or whatever. When Ilya did the consciousness tweet, they're like, God damn, GPT-4 must be crazy. Like there's a zillion VCs throwing money at large language model startups right now. At some point, like Beijing Academy of AI is gonna be like, look, we just trained like a 10 to the 15 parameter model on all of YouTube and spent like $40 billion doing it. And then at that point, like Jared Kaplan's going to be like in the White House press conference room being like, look, see these straight lines on log plots. We gotta do this in the USA now.
The Inside View.
The Inside View.
The Inside View.
Ethan, you're a master's degree student at Mila in Montreal. You have published papers on out-of-distribution generalization and robustness generalization, accepted as oral presentations and spotlight presentations at ICML and NeurIPS. You've recently been thinking about scaling laws, both as an organizer and speaker for the first neural scaling laws workshop in Montreal. You're currently thinking about the monotonic scaling behaviors for downstream and upstream tasks, like in the GPT-3 paper. And most importantly, people often introduce you as the edgiest person at Mila on Twitter. And that's the reason why you're here today. So thanks, Ethan, for coming on the show, and it's a pleasure to have you.
Likewise.
You're also well known for publicizing some sweatshirts mentioning scale is all you need, AGI is coming.
Yeah.
How does those sweatshirts appear?
Yeah, there was a guy named Jordi Armongo Estape who interned at Mila, and he got really into scaling laws apparently via me. And then he like sent me the shirt and be like, look how cool this shirt is. Like he's the person wearing the shirt in the picture. And he's like, look how cool this shirt I just made is. And so then I tweeted the shirt. And then Irina just turned it into a merchandising scheme to fund future scaling law conferences. So she just made a bunch and started selling it to people. Like apparently like she sold like more than 10 to Anthropic already. Just scaling law t-shirts, that's the optimal funding model for supercomputers.
Maybe you can like explain intuitively for listeners that are not very familiar what are scaling laws in general.
Whatever your bottleneck compute data or parameters, you can predict what the performance will be as that bottleneck is relieved. Currently, the thing most people know how to do is predict like the upstream performance. Like the thing people want though is to be able to predict the downstream performance. And upstream is what you're like, it's like your literal loss function that you're optimizing. And then downstream is just any measure that you have of like something you care about. So just like a downstream data set, or like, I mean, usually it's just mean like accuracy on a downstream data set.
And to take like concrete examples, like for GPT-3, the upstream task is just predict the next word. What are the downstream tasks?
Like 190. It was a zillion like benchmarks that the NLP community has come up with over the years. Like they just evaluated like the accuracy and like things like F1 score on all those.
And yeah, what should we care about upstream and downstream tasks?
I mean, basically, like, well, we don't really care about upstream that much. Upstream's just the first thing that people knew how to predict, I guess. Like, predict the scaling of. What we care about is downstream. I mean, basically, like downstream things that improve monotonically, they kind of can be interpreted as like capabilities or whatever. And then downstream stuff that doesn't necessarily improve monotonically often is stuff that is advertised as alignment stuff. So like toxicity or like if you like speculate in the future, stuff like interpretability or controllability would be things that might not improve monotonically.
So you don't get more interpretability as you scale your models?
You do currently, but like the classic example is like Clip, it gets more interpretable as it like has like representations that make more sense. But you can imagine at a certain point like it's less interpretable because like then at a certain point like it the concepts it comes with are like beyond human comprehension. Like now just how like dogs can't comprehend calculus or whatever.
Yeah. When you mention alignment, what's the easiest way for you to define it?
I mean, it's like the Anthropic definition is pretty practical. Like we want models that are helpful, honest, and harmless, and that seems to cover all the like weird edge cases that people can like come up with on alignment form or whatever.
Gotcha. So it's not like a technical definition; it's more a philosophical one.
Yeah, yeah.
So, would you consider yourself an alignment researcher, or more like a deep learning researcher? But
I'd say just a beneficial AGI researcher. That seems to cover everything.
what's AGI?
The definition on OpenAI's website is pretty good. Highly autonomous systems that outperform humans at most economically valuable tasks.
When do you think we'll get AGI?
I'll just say like it depends mostly on just like compute stuff, but I'll just say 2040 is my median.
What's the your like 10% and 90% estimates?
10%, probably like 2035.
I think there's been a week where we got DALL-E 2, Chinchilla, Palm. Did that like update your models in any way?
The one that I thought was the crazy day was the day that AlphaCode and the math proving thing happened on the same day. Because like especially the math stuff, like Dan Hendricks has all those slides where he's like, oh, math has the worst scaling laws or whatever, but then like OpenAI has like the IMO stuff. So like at least according to like Dan Hendricks slides or whatever, that would have been like something that took longer than it did.
So when you mentioned the IMO stuff, I think it was like a problem from maybe 20 years ago, and it was something that you can like do with maybe like 2 lines of math.
I agree they weren't like super impressive, but it's more just the fact that math is supposed to have like the worst scaling supposedly, but like impressive stuff's already happening with math now.
Why is math supposed to have the worst scaling?
It's just an empirical thing. Like Dan Hendricks has that like math benchmark thing, and then he tried to do some extrapolations based on the scaling of like performance on that. With the amount of compute and data we currently have, it's already like doing interesting stuff was kind of surprising for me.
I think in the paper they mentioned that the method would not really scale well because of some infinite action space when trying to think of like actions.
Yeah.
So yeah, I didn't update as like, oh yeah, scaling will be easy for math.
I didn't update it as easy, but just easier than I had thought.
Okay. Related to scaling, the paper by DeepMind about the Chinchilla model was the most relevant, right?
Yeah, although I thought it was interesting. Like, yeah, I mean, you probably saw me tweet it. Like that person on a Luther Discord that was like, "Oh wait, Sam Altman already said this like 6 months ago, but they just didn't put it in a paper."
Yeah, he said that on a Q&A, right?
Yeah.
Yeah, he said something like we shouldn't. Our models will not be like much bigger.
Yeah, he said they'll use way more compute, which is analogous to saying that you'll train a smaller model but on more data.
Can you like explain the kind of insights from scaling laws between like compute model size, like the what's called like the Kaplan scaling laws?
It was originally something like computing. If your compute budget increases 1 billion-fold, your model size increases 1 million-fold, and your data set size increases 1,000-fold. And now it's something like I know it's like 1-to-1, but I don't remember like how big the model size to like compute ratio was. Like I know like the model to data ratio is 1-to-1 now, but I don't remember what the compute to model ratio is. The new compute to model ratio is.
That's also what I remember, and I think like the main insight from the first thing you said from the Kaplan law is that like model size is all that matters compared to data set, and so for a fixed compute budget.
Yeah, the narrative with the Kaplan one was model size, like compute is the bottleneck for now until you get to the intersection point of the compute scaling law and the data scaling law. And at that point, data is going to become more of a bottleneck.
So compute is the bottleneck now. What about like having huge model?
But yeah, that's like because like they were saying that because model size grows so fast, to get the bigger models, you need more compute rather than like you don't need more data because like you don't even have enough compute to like train an optimally large model on that data yet. With the current compute regime was the narrative of the original Kaplan paper, but it's different now because like the rate at which you should be getting data given like the rate at which your data set size should be increasing given your compute budget is increasing is a lot faster now, like using the chinchilla scaling law. For some increase in compute size, you're going to increase your model by a certain amount, and the amount that your data set size increases is like a one-to-one relation to the amount that your model size increases. I don't remember what the relation between model and compute was, but I know that now the relation between model and data set size is 1-to-1. Between model size and data set size is 1-to-1.
And the main insight is that now we can just have more data and more compute, but not like a lot of more compute. We just need the same amount as more compute, so we can just like have scrap the internet and get more data.
It just means like to use your compute budget optimally, the rate at which your data set size grows is a lot faster. Like because all this stuff's like one epoch training.
Does that make you more confident that we'll get like better performance for models quicker?
Maybe for like YouTube stuff, because YouTube we're not bottlenecked by data. We're bottlenecked by compute or whatever. But that implies like the model sizes might not grow as fast for YouTube or whatever. But for text, we're probably going to be bottlenecked by. It means we're probably going to be bottlenecked by like text and like code. By the data set size earlier than we thought. But for YouTube, that might like speed up the video unsupervised video on all of YouTube like timeline stuff.
Yeah, so I'm curious what you think about like how much are we bottlenecked by data for text?
Yeah, I asked Jared Kaplan this, and he said it was 300 billion tokens for GPT-3, and then he said like Library of Congress, whatever, could be 10 trillion tokens or something like that. And so like the most pessimistic estimate of how much like the most capable organization could get is the 500 billion tokens. A more optimistic estimate is like 10 trillion tokens is how many tokens like the most capable organization could get, like of mostly English tokens.
So how many like orders of magnitude in terms of like parameters does this give us?
I don't remember I haven't calculated it. Like I remember I kind of did it with the old one, but I haven't done it with the new chinchilla one. But he like I mean you said this in your thing today or whatever. Like we probably are going to be bottlenecked by the amount of code.
I was essentially quoting Jared Kaplan's video.
Yeah, but he's right. I'm kind of wondering what's Anthropic thinking of Adept, because Adept's like doing the like train on all the code thing, and Anthropic was going to do the train on all the code thing, and they're like, oh crap, we got another startup doing the train on all the code stuff.
Yeah, so I think he said that if you remove the duplicates on GitHub, you get some amount of tokens, maybe like 50 billion tokens, 500. I'm not sure, maybe 50 billion. Don't quote me on that. And yeah, so the tricks will be data augmentation, do some AlphaGo stuff where you're doing like apply the like RL things to make your model better, but it's not clear how do you improve performance. So my guess would be you do transfer learning, like you train on like all the different languages.
That's definitely what they plan on doing. Like you've seen the scaling lots for transfer paper is literally pre-train on English and then fine-tune on code.
My guess is also that like if you get a bunch of like the best programmers in the world to use Copilot, and then you get like feedback from what they accept, you get higher quality data. You get just like, oh yeah, this works, this doesn't work, and so you have like 1 million people using your thing 100 times a day, 1,000 times a day. Then that's data for free.
I mean, I view that part kind of as like the human feedback stuff is kind of like the alignment part is the way I view it. I mean, there's some people who like say, oh, there might be ways to get like better pre-training scaling if you have like humans in the loop during the pre-training, but like no one's really figured that out yet.
Well, don't you think like having all these telemetric data from GitHub Copilot is you can use it, right?
Yeah, but I almost view it as like that. It's like used for alignment, like for like RL from human preferences
Oh,
type
okay,
stuff.
gotcha. Yeah, I think the other thing they did for improving GPT-3 was just having a bunch of humans rate the answers from GPT-3, and then like that's the paper of Instruct GPT. I think like they had a bunch of humans, and it kind of improved the robustness of, or not robustness, but alignment of the answer somehow. Um, like it said less like non-ethical things.
Yeah, I mean it's like because like people like downvoted the non-ethical stuff. I think.
Exactly. Yeah, and to go back to YouTube, so why is kind of YouTube interesting? So there's unlimited data.
Yeah, one you're not bound by. I mean, the gist is YouTube's the most diverse, like simultaneously diverse and large source of like video data, basically.
And yeah, so for people who are not used to or thinking, what's the task in YouTube?
Yeah, it could be various things. Like it might be like a contrastive thing, or it might be a predict all the pixels thing. Like, I mean, so like at least places like Facebook seem to think like contrastive has better downstream scaling laws, so it's going to be a contrastive type thing.
What's contrastive, that type thing?
Like, you want representations that have similar like semantic meaning to be close together, like to have low cosine similarity, like in latent space. Um, to basically like maximize the mutual information uh, between views. Like it's kind of hard to explain without pictures. uh,
So you'd say that your model takes a video, like all of the videos and views as input,
Frames that were close together, uh, like in time, it tries to maximize the mutual information between them via like minimum, uh, via maximizing cosine similarity between the latents of like a like a resonant encoder or whatever that encodes the images for both of those frames that were next to each other, like in time.
so he tries to kind of predict correlations between frames in some kind of latent space from a ResNet.
Yeah. In the latent space, you want frames that were close to each other in time to have similar like maximize the cosine similarity between the latent space between the hidden the hidden layer output by the like resonance that took each of those frames in.
And at the end of the day, you want something that is capable of predicting how many frames in advance.
Kind of for well the like philosophy with like the contrastive stuff is we just want a good representation that's useful for downstream tasks or whatever. So like you don't actually like there's no like output really. It's just you're training a latent space or whatever that can be fine tuned to downstream tasks very quickly.
What are the useful downstream tasks like robotics?
Yeah. Like there's a zillion papers on like people pre-train on do some pre-trained contrastive thing in like a OpenAI gym or like Atari environment, and then they show like, oh, now we barely need any RL steps to like fine tune it or whatever, and it can like learn RL really quickly after we just did all this unsupervised contrastive like pre-training or whatever.
And yeah, wouldn't your model be kind of um, shocked by the real world when you just like show him like YouTube videos all the time, and then you try to throw the robot with like a camera?
Kind of not real. I mean, because there's like everything on YouTube. They got like first person egocentric stuff. They got third person stuff. Like it'll just like realize which like whether it's in first or third person pretty quickly. I feel like it just infers the context. Like Analogy.GPT-3 just infers the context it's in because it's seen like every context ever.
Gotcha. So I was mostly thinking about like entropy of language.
If it's literally like a video generative model, then you can do like just the perfect analogies to GPT-3 or whatever. It gets a little trickier with like contrastive stuff, but yeah, I mean either one. The analogies are pretty similar for either one.
So one of the things about the scaling laws papers, the neural scaling laws, there was some different exponents for text.
Yeah.
What do you think is the exponent for video? Would it be like much worse?
I know the model size relation was the big plot twist of the scaling laws for autoregressive generative models paper was that the rate at which the model size grows, given your compute budget grows, is the same for every modality. So that was kind of like, that's like a big unexplained thing. Like that was like the biggest plot twist of that paper, and like no one's been able to explain why that is yet.
So there might be some universal law where scaling goes for all modality, and nobody knows why.
Just this stuff, the rate at which your model size grows, given your compute budget is increasing, is the same for every modality, which is kind of weird, and no one, I haven't really heard a good explanation why.
Who do you think will win the video prediction race?
The person who wins AGI is whoever has the best funding model for supercomputers. Whoever has the best funding model for supercomputers wins. Like, I mean, you have to assume all entities are like, they have like the nerve, like we're going to do the biggest training run ever. But then given that's your pre-filter, then it's just whoever has the best funding models for supercomputers.
So who is able to spend the most money? So would it be USA, China, Russia?
Yeah, it might be something like, I mean, my guess is like China's already like they already have like this like joint fusion of like industry, government, and academia via the Beijing Academy of AI in China. So my guess is like at some point like Beijing Academy of AI is gonna be like, look, we just trained like a 10 to the 15 parameter model on all of YouTube and spent like $40 billion doing it. And then at that point, like Jared Kaplan's going to be like in the White House press conference room being like, look, see these straight lines on log plots. We gotta do this in the USA now.
Right. Right. But like, how do you even spend that much money?
By making people think if they don't, they'll be like, they'll like, you know, they'll no longer be the superpower of the world or whatever. Like China will take over the world or whatever. Like it's literally like a fear. It's literally a fear thing.
From looking at the Palm paper from Google,
Yeah.
they seem pretty clever on how they use their compute.
You mean that thing where they have like the two supercomputers that they split it across or whatever?
Right. I think TPU pods or something they call it.
Yeah.
So it didn't seem like they spent more money than OpenAI. So they try to be more careful somehow. So my model of like people spending a lot of money is
like most entities won't be willing to like do the largest training run they can given their funding.
So maybe China, but I see Google as being more careful because of the Palm paper, but maybe I'm wrong.
Jared Kaplan says like most like Anthropic and OpenAI are kind of unique in that they're like, okay, we're gonna like throw all our funding into this one big training run. But like Google and like, because Google and Amazon, they have like, he said like at least 10x or like 100x times the compute that OpenAI and Anthropic have, but they never like use all the compute for single training runs. They just, have all these different teams that use the compute for these different things.
Yeah, so they have like a different hypothesis. OpenAI is like scale is all that matters. Somehow that's their secret sauce. And
yeah, something like that.
you can just like scale things and we're going to get better results. And Google is maybe there's more bureaucracy and it's maybe harder to get a massive budget.
Yeah, it's weird though, because like Jeff Dean's like latest like blog post that summarizes all the like Google's research progress mentions like scaling laws a zillion times. So that almost implies that like they're on the scales all you need bandwagon too. So I don't know.
They probably know, but then the question is how like private things are, and maybe there's stuff we don't really know.
I know a bunch of people at Google said like, yeah, we have language models that are way bigger than GPT-3, but we just don't put them in papers.
So you've talked to them like privately, or is it just they say it online?
I've heard things from people, and that's what they say. I'm not disclosing where I got that information from, but that's just right. What I've heard from people.
So as we're on like gossip, I think like something that was around on the internet, like right when GPT-3 was launched, was that Google was like reproduced it in a few months afterwards, but they didn't really talk about it publicly. I'm not sure about what to do with this information.
I know that like the DeepMind language models papers, they were a year old when they finally put them out on on archive or whatever, like Gopher and Chinchilla. They had the language model finished training a year before the paper came out.
So we should just like assume all those big companies are just like throwing papers when they're like not relevant anymore, when they have like the other paper already ready.
Maybe, but yeah, I don't know why it was delayed that much. Yeah, I don't know what the story is. Why it was delayed that long.
People want to like keep their advantage, right?
I guess, but I mean, like, I feel like GPT-3, they threw the paper on archive pretty soon after they finished training GPT-3.
How do you know?
Yeah, I don't. But I mean, yeah, I don't. But it, at least it didn't. Yeah, maybe there was a big delay. I don't know.
So I think you could just like retrace all Sam Altman tweets, and then like you read the next paper like 6 months after, and you're like, oh yeah, he tweeted about that. Like sometimes he tweets like, oh, AGI is going to be wild, or oh, neural networks are really capable of understanding. I think he tweeted that like 6 months ago. That maybe was like when they discovered GPT-4.
Funny is like when Ilya did the consciousness tweet, they're like, God damn, GPT-4 must be crazy.
Yeah, neural networks are in some way slightly conscious.
Yeah. That was the funniest quote tweet.
Yeah, I think people at OpenAI know things we don't know yet. They're all like super hyped. And I think you mentioned as well that at least previously that like Microsoft had some deal with OpenAI, and so they need to spend some amount of money before 2024. Like,
oh yeah. I mean, right when the Microsoft deal happened, like Greg Brockman said, like our plan is to train like a 100 trillion parameter model by 2024.
okay, so that's in 2 years.
I mean, that was in 2019, but maybe they've changed their mind after like the chinchilla scaling law stuff. I don't know.
Right. And so you were not like impressed by Palm being able to predict, to like do logic on airplane things and explain jokes.
In my mind, like the video scaling law is like a lot worse than text, basically. That's the main reason why like AGI will probably take longer than 5 years or whatever, in my mind.
Okay, so we need, so if we just have text, then it's not enough to have AGI. So if we have like a perfect oracle that can like talk like us, but is not able to like do like robotic things, then we don't have AGI.
Yeah.
Well, I guess my main bottleneck is mostly like coding. So if we get like coding, like Codex or Copilot that gets really good, then everything like accelerates and engineers become very productive. And then like,
Yes, if you could say like engineers get really productive at making improvements in hardware, then like maybe that would, like, I get how that would like be like, okay, then it's really fast. But like in my mind, at least at the current rate, I don't see the hardware getting fast enough to like be far enough along like the YouTube scaling law in less than 5 years from now.
think about hardware. We're just like humans googling things and using.
Yeah, I get what you're saying. Like you get the Codex thing, and then we use Codex or whatever to design hardware faster.
Imagine you have like DALL-E, but like for designing chips.
I mean, NVIDIA already uses AI for designing their chips.
That doesn't make you like think of timelines of 10 years or closer.
Maybe 10 years, but not 5 years. The thing I'm trying to figure out is like try to get like a student researcher gig at like someplace so that I can just get access to the big compute during the PhD.
Oh, so that's your plan. Just get a lot of compute.
Yeah. I mean, as long as I have big compute, it doesn't matter where I'm a PhD. I mean, it kind of matters if you're like trying to start an AGI startup or whatever, but safe AGI startup.
we're kind of on record, but I'm not sure if I'm going to cut this part, so you can say unsafe. It's fine.
Yeah. No. I mean, I don't even phrase. I just phrase it as beneficial AGI. I don't know.
He was spotted saying he wanted unsafe AGI the fastest possible.
No. The way I phrase it is, I think I explained this last time. You have to be thinking in terms of the fastest path because there's like extremely huge economic and military incentives that are selecting for the fastest path, whether you want it to be that way or not. So like you got to be thinking in terms of what is the fastest path, and then how do you like minimize the alignment tax on that fastest path? Because like the fastest path is the way it's probably going to happen no matter what. Like so, it's about minimizing the alignment tax on that fastest path.
Or you can just throw nukes everywhere and try to make things slower.
Yeah, I guess, but I mean, the people who are on the fastest path will be like more powerful, such that like I don't know, such that they'll like deter all the nukes.
So you want to be okay. So you want to just like join the winners. Like if you join the scaling team at Google, or
Thing I've been trying to brainstorm about is who's going to have the fastest, who's going to have the best funding models for supercomputers, because that's the place to go, and you got to try to minimize the alignment tax at that place.
makes sense. So yeah, everyone should infiltrate Google.
Just whatever place ends up with the best funding model for supercomputers, try to get as many weird alignment people to like infiltrate that place as possible.
So I'm kind of happy of having a bunch of EA people at OpenAI now, because they're kind of minimizing the tax there. But
yeah, I kind of viewed it as all the EA people left, like because Anthropic was like the most extremist EA people at OpenAI. So I almost viewed when Anthropic happened, a bunch of EA people left. I viewed it as that like EA almost leaving OpenAI when Anthropic happened.
but some other people came, right?
Like who?
I don't know, Richard Ngo.
Oh, okay. Yeah.
He has like a team on like predicting the future.
Yeah, but yeah, I want to know what the futures team does because that's like the most out there team. I'm really curious what they actually do.
Maybe they use their GPT-5 model and predict things.
Like, because I mean, like Daria, like you know about the Foresight team at OpenAI, right?
They were trying to predict things as well, like forecasting.
Yeah, that's where all this scaling law stuff came from. Was from the Foresight team at OpenAI. They're gone now because they became Anthropic. But like a team called like the Futures team that almost has a similar vibe to like a team called the Foresight team. So I'm kind of curious.
Maybe they're just like doing more governance things and optimal governance and maybe economics.
That's what it's about, governance and economics.
The guy like Richard Ngo is doing governance there.
Okay.
Predicting how the future works, I think, is in his Twitter bio.
Yeah. But I mean, that's somewhat tangential to governance. Like that almost sounds like something like Ray Kurzweil would say. I'm predicting how the future will.
My model is like Sam Altman as like they have GPT-4, like they published GPT-3 in 2020, so it's been like 2 years. And
Yeah.
they've been talking about like in their Q&A about like Chinchilla's results or something like 1 year ago. So now they must have access to something very crazy, and they're just like trying to think like how do we operate with like DALL-E 2 and their GPT-4 they have in private, and how do they do something without like fucking up the world? I don't know. Maybe they're just like trying to predict like how to make the most money with their API. Or
You're saying like if they release it, it's like an info hazard? Because in my mind, like GPT-4 still isn't like capable enough to f up the world, but you could argue it's like capable enough to like be an info hazard or something.
Imagine you have access to something that does the same kind of gap between GPT-2 and GPT-3, but like for GPT-4, on like in understanding and being general.
Uh-huh.
And you don't want everyone else to copy your work, so you're just going to keep it for yourself for some time.
Yeah, but I feel like that strategy is already kind of screwed. Like, you know about how like a zillion large language model, like a zillion Googlers have left Google to start large language model startups. Like there's literally 3 large language model startups by ex-Googlers now. Like, OpenAI is like a small actor in this now because there's like multiple large language model startups founded by ex-Googlers that all were founded in the last like 6 months. Like there's a zillion VCs throwing money at large language model startups right now. The funniest thing, like Leo Gao, he's like, we need more large language model startups because the more startups we have, then it splits up all the funding. So no organization can have all the funding to get the really big supercomputer. So we just need thousands of large language model startups. So no one can hoard all the funding to get the really big language model.
That's the Eleuther AI model. You just like do open source, so like there's like more startups, and so all the funding gets split, I guess.
Yeah, you could view OpenAI was like extra big brain. We need to like release the idea of large language models onto the world such that no organization could have enough compute to like be such that all the compute gets more split up because a zillion large language model startups will show up all at once.
That's the best idea ever. So do you have like other gossips besides like Google's? Did you post something on Twitter about people leaving Google?
Yeah, I posted a bunch of stuff. Well, I mean, and also like you saw I mean, it's three startups: Adept.ai, Character.ai, and Inflection.ai. They're all large language model startups founded by ex-Googlers that got $1 zillion in VC funding to scale large language models.
What's $1 zillion like?
Like greater than 60 million. Each of them got greater than 60 million.
So that they know about something we don't know, and they're just like get money to replicate what Google does.
Well, I mean, most of them there were famous people, like founder of DeepMind scaling team. Another one is the inventor of the transformer. Another one was founded by a different inventor of a different person on the transformer paper. Like, so I mean, they in some ways they have more clout than like OpenAI had or whatever.
But they don't have like the engineering and all the infrastructure.
No, they kind of do. Like, a lot of them they were like the head of engineering for scaling teams at like DeepMind or Google.
So there's like another game that is in private at Google, and they've been scaling huge models for 2 years, and they're
Yeah,
just like
something like that.
starting startups with their knowledge and their huge scaling, and we just like peasants like us talk about papers that are released 1 year after that nobody
Yeah.
thought about.
Yeah. I guess that's. I mean, I don't know how long these delays are. I mean, in my mind, like, yeah, I guess you could view it as a delay thing, but because like in my mind, it's just like, yeah, you're right. You're right. It's probably delayed by a year. Yeah.
So yeah, that makes me less confident about
Oh
allowing.
shit! You look like a clone of Lex Friedman from the side.
What?
When your face is like sideways, you look like a clone of Lex Friedman.
Okay,
Like, cause your haircut's like identical to his. When
I'll take it as a compliment that I've done a lot of workout, and now I can just look like Seth Lifterman. So yeah, Ethan Cavallero was the meaning of life.
Probably just maximize the flourishing of sentient beings, like a very generic answer.
Right. So I've done my Lifterman question. Now I'm just basically him.
Yeah.
Maybe we can just go back to like stuff we know more about, like your work, and because you've been doing some work on scaling.
Yeah.
So like more general, like why are you kind of interested in scaling, and like how did you get started on like doing research on that?
I mean, I knew about the Baidu paper when it came out. Like, I remember I was at this like Ian Goodfellow talk in 2017, and he was hyped about the Baidu paper when it came out.
Which paper?
The deep learning scales predictably empirically. Yeah, it came out in 2017, and then I kind of just that was just on the back burner, and I kind of just stopped paying attention to it after a while. And then like Aaron Kamatsuzaki was like, "No, dude, this is the thing. Like, this is going to take over everything." And this was like in 2019 when he was saying that. And then yeah, so then when the scaling laws papers got like repopularized through like the OpenAI stuff, then I kind of like caught onto it a little bit early via like talking with Aaron.
I think in 2019 was also when GPT-2 paper was introduced.
But that was kind of before like the scale, like that was before like the scaling law stuff kind of got popularized.
Right. Canello's paper is 2020.
Yeah, the very end of 2020. All right, no. Oh no. The scaling law paper was the very end of 2000. It was the very beginning of 2020.
And you were already on the scaling train since 2017.
I was aware of it, like, but I didn't like. I was kind of just neutral about it until like 2000, like probably the middle of 2019.
And yeah, now you're kind of interested in scaling because it's useful to predict kind of where the whole field of AI is going.
And also, it's I think people underestimate how easy it is to be contrived if you're not paying attention to scaling trends and trying to like extrapolate to compute budgets and data budgets that are like will be the compute data and data budgets in like 5 years from now.
Yeah, if you're a huge company that has a lot of budget, but maybe if you're just a random company, you don't really care about scaling law that much.
Yeah, yeah. Or if you're like in academia currently or whatever, it like like a zillion papers at like fancy conferences. They're like, here's our inductive bias that helps on like our puny academic budget, and we didn't test any of the scaling asymptotics to see if it's like useful when you're like training a trillion parameter model on all of YouTube or whatever.
You're on an academic budget, as far as I know. So how do you manage to do your experiments and scaling?
There's like the scaling law narrative that's like, oh, you don't need the big budget because you can just predict what the outcomes will be for the large scale experiments. But that's at least when that narrative got popularized, it was mostly for upstream like scaling. But the thing everyone cares about is downstream scaling.
Yeah. So if we go back for a minute on like your work in alignment, how do you think your work on scaling or generalization like kind of fits with the alignment problem?
Basically, all alignment, I guess this triggers the hell out of some people, but all alignment is inverse scaling problems. It's all downstream inverse scaling problems. So it's just, in my mind, all of alignment is stuff that doesn't improve monotonically as compute data and parameters increase.
There's a difference between not improving and inverse scaling. Inverse scaling goes badly, right?
Yeah, but I just said not improve monotonically because like sometimes there's certain things where like it improves for a while, but then at a certain point it gets worse. So like interpretability and controllability are the two like kind of thought experiment things where you could imagine they get more interpretable and more controllable for a long time until they get super intelligent. And at that point, they're like less interpretable and less controllable.
Do we have benchmarks for controllability, or
like just benchmarks that rely on prompting as a form of like a benchmark of controllability?
And kind of to summarize your take, if we were able to just scale everything well and not have this inverse scaling problem, we would get like interpretability and controllability and everything else by just like good scaling of our models. And so we'd get like alignment kind of by default for free.
Yeah. I mean, I guess. I mean, like there's stuff besides interpretability and controllability. Like those are just the examples. Like what you said, you asked like, what's an example where like the reason I phrased it as alignment is when I said inverse scaling, I said things that don't improve monotonically. Because I just wanted to say like, yes, there's obvious examples where it gets worse the entire time, but there's some you could imagine where it gets good for a long time, and then at a certain point, then it starts getting drastically worse. I said all of alignment can be viewed as a downstream scaling problem. The hard part is like Dan Hendricks and like Jacob Steinhardt say like, then the hard problem though is like measurement and like finding out what are the downstream evaluations. Like, cause say you got like some like fancy like deceptive AI that wants to do like a treacherous turn or whatever. Like how do you even find the downstream evaluations to know whether it's going to like try to deceive you or whatever? Cause like when I say it's all a downstream scaling problem, that assumes like you have the downstream task the downstream like thing that you're evaluating it on. But like if it's like some weird deceptive thing that's like, it's hard to even find what's the downstream thing to evaluate it on to like know whether it's trying to deceive you or whatever.
So there's no like test lost on the deception. We don't know for sure how to measure and have a clear benchmark for this.
Yeah, it's tricky. I mean, and some people say like, well, that's why you need better interpretability. You need to like find the deception circuits or whatever.
Knowing that we don't know yet like all the different benchmarks and metrics for misalignment, don't you think that your work on scaling can be bad because you're actually like speeding up timelines?
Yeah, I get that like info hazard point of view, but like in my mind, like whether you want to do all capabilities or alignment stuff that stands the test of time, you need really good downstream scaling prediction. Like say you came up with some like alignment method or whatever that mitigates inverse scaling. Like you need the actual functional form to know whether that thing will like keep mitigating inverse scaling when you get to like a trillion parameters or whatever. Oh, you get what I mean?
I get you, but like on a like different differential progress mindset, like Jared Kaplan or someone else will come up with those functional forms without your work.
I don't know. I don't know. I mean, that's the thing though. Like Anthropic got that paper like predictability and surprise and generative models, and they're just like it's unpredictable. We can't predict it. And I'm like, you guys, nah, I don't believe.
Right. So you're kind of publishing papers 1 year in advance because those companies are not publishing their results.
I don't know. I don't. Yeah, I don't know if Anthropic does the delay type stuff that OpenAI supposedly does, but maybe they do. I don't know.
And you're just like throwing info hazard by publishing those laws.
I mean, in my mind, like whether or not like I get the argument like, oh, it like if you want to do capabilities work that stands the test of time or alignment work that stands the test of time, like in my mind, like everything that people are doing in alignment will be very contrived without the functional form too, though. So it's like alignment can't make progress without it either. So it's like, you get what I mean?
I have like another kind of view on that is that if people do impressive deep learning or ML work and are also interested in alignment, it's still a good thing. Like let's take Eleuther AI. Even if they open source their model because they did something impressive and they talk openly about alignment on their Discord, then gets like a lot of people that are very smart interested in alignment. So if you publish something and you become like a famous researcher or something in 2 years, and you talk about alignment in 2 years, then it's fine.
I sort of tweet stuff about alignment, I think. Yeah, I mean, I retweet stuff about alignment at least.
So if we go back to thinking about like predicting future timelines and kind of scaling, I've read somewhere that you think that in the next few years we might get billion or trillions times more compute, like 12 orders of magnitude more.
Yeah, I mean the Ajaya Kocher report said like it's going to max out probably at 10 to the 12 times as much compute as like the amount of compute in 2020, probably like 2070 or something like that. The one issue I have with Ajaya's model is that like she said she does what does she do? It's like it's flops per dollar times willingness to spend is total flops that are allocated to pre-training runs. Problem is like for the big like foundation models, like 10 of the 15 parameter models of the future or whatever, you're probably going to need high like memory bandwidth between like memory bandwidth and compute bandwidth between all the compute, which means it has to be on a supercomputer. So like it's not just the flops. It basically what really matters at least if you're assuming it's like big like 10 to the 15 parameter foundation models or whatever, like it's the speed of the fastest supercomputer is what matters, not just the total flops that you can allocate. Because if like all the flops don't have good communication between them, then they aren't really useful for training like 10 to the 15 parameter model or whatever. Once you get to 10 to the 15 parameters, like there isn't much reason to go beyond that. And at that point, you just have multiple models with 10 to the 15 parameters, and they're like doing some crazy open-ended like Ken Stanley stuff in a multi-agent simulator after you do the like if it eventually became like you do the 10 to the 15 parameter model pre-trained on all of YouTube, and then after that you'll have like like hundreds of 10 to the 15 parameter models that all just like duke it out in like a Ken Stanley open-ended simulator to like get the rest of the capabilities or whatever. Like once they're in the Ken Stanley open-ended simulator, then you don't need high compute bandwidth between all those individual like 10 to the 15 parameter models like duking it out in the simulator. They can just each one, it only needs like it only needs high compute bandwidth between like its own parameters. Like it doesn't need high compute bandwidth between itself and the other like agents or whatever. Like and so like and there like the flops, you could use all the flops for like the multi-agent simulation, but you only need high compute bandwidth within each agent.
So you need a lot of bandwidth to train models because of the parallelization thing, but you only need flops to simulate on different things at the same time.
Yeah, you only need high compute bandwidth within an individual brain, but like if you have multiple brains, then you don't need high compute bandwidth between the brains.
And what's the kind of simulator you're talking about? The Kenley?
Like Ken Stanley, the open-ended guy.
I haven't seen that.
Ken the myth of the objective, open-endedness, like Ken Stanley, Jeff Clune, like all that stuff. It's like I don't know. Just Google like Ken Stanley open-ended at some point. Like
Gotcha.
you probably heard of it, but it's not like registering like what I'm referencing.
Okay, so maybe one kind of last open-ended question. On a scale from Paul Christiano, Eliezer Yudkowsky, Sam Altman, how like optimistic are you about
I'm
alignment?
definitely not like Elijah or Doomer type person. I guess probably Paul Cristiano is the most similar. I mean, I feel like Paul Cristiano is in the middle of the people you just said.
Right, yeah. So you're less optimistic than Sam Altman.
Well, yeah. I mean, basically, I think deceptive AI is probably gonna be really hard.
So do you have like one last monologue or sentence to say about why scaling is the solution for all alignment problems?
Like just all of alignment can be viewed as an inverse scaling problem. Like it all revolves around just mitigating inverse scaling, but also you have to make sure you have like the right downstream things that you're evaluating, like the inverse scaling on. And like part of what makes it hard is like you might need to do like fancy thought experiments on alignment, like counterintuitive thought experiments on alignment form to find what are the downstream define what are the downstream tests that you should be evaluating, like whether or not there's inverse scaling behavior on those.
Awesome. So we get the good version as the last sentence. And that's a conclusion for the podcast. Thanks, Ethan, for being on the show.